Are you able to see my screen?
Yes, I sure can.
Okay, so I got the question up. It says sketch the graph of log 1/2 x, and you're supposed to know that the log usually looks like that. This one, because this base is less than 1, it ends up having this shape to it.
Mhm.
So then we're just figuring out, well, what's the change on this? Like, what does this cause it to do? Well, it goes down 2 units right there. So it's the exact same graph. It's just down 2 units like that. Do you know if you have to give a table or just is that good enough? Like, is it good enough just
Um,
to show that, or do you need to give a table of values?
I think that it's fine if we just show the graph.
Yeah. Okay. So I mean, I haven't done it great, but it just has the shape of going down 2 units from the original.
Ah, okay.
How about 29? Is that needed?
Yeah, we go to. Let me check that. 29. Yes.
All right. 29. This one is got the -2 inside the function.
Mm-hmm.
So that means that it's going either left or right 2. This one is a right 2 because of that. So the normal graph, it has a vertical asymptote here at x equals 0, and it looks like this. The 2 moves it over 2 units, and then it's got this shape like this. Same exact shape, just out to the right.
Alrighty. So take it out to the right. All right. On to number 39 through 41 all.
39 through 41 all. Okay. 39. Okay, this is again, it's just a graph. Okay, like, and to me, I don't know what that means, if it means like really exact or not. It doesn't matter what the base is here, as long as this base is greater than 1, it always has this shape to it.
Okay.
So like, we're done. I mean, but if you need like a table, we're not done because we got to put some values in. But it always has that shape of what a logarithm looks like.
Let me check the answers in the back to make sure that it's not like leaving anything out. See, we're on 5.4. No, that doesn't ask for anything else. We're good for now. All right, on to number 40.
Okay, so we're doing
Log 10x.
log 10x. Log base 10 of x. So it has the same shape. Like you could literally draw the same graph I just created. It is, if you were to overlay the two, though, it would be slightly different, meaning like one would be under another.
Mm-hmm.
This one is flatter compared to this one.
Yeah.
Um, that's it. I mean, there's nothing more to do here. That's why I keep asking, like, is there anything else? Because
Mm-hmm.
these are not good questions. They're not testing like your understanding of transformations, and but this next one kind of does. So
41, yeah.
yeah, 41 does. So 41's got a lot going on here. This base of 1/2, it has the effect of flip over the x-axis. Now this is a little bit weird, this 1 minus x. If you rewrite it as log 1/2 minus x plus 1, and then you factor out a -1 from both, so you get log 1/2 minus x minus 1. Okay, you realize that this is a shift right. This is right 1. But this
Oh,
right
okay.
here, this negative in front, is a flip over the y-axis. So now it's like, well, what order do we do it in? Well, that does matter. It's right one first, then flip over the y-axis, then the x-axis. So let me try to diagram that here. Sorry, I scrolled a little too far. So this is the original graph. Okay,
Okay.
right one flips it. Right one is like this. Over the y-axis is like this, and then over the x-axis is like this. So this is your graph. Sorry, no, I got the order. I'm sorry, I completely got the order wrong. Oh, this is bad. The I'm so sorry. I got the order completely wrong. Just doing a terrible job of explaining this. Okay. It ends up looking like this. So right one is this part. The flip over the y-axis is why it's going to the left here, and then over the x-axis is why it doesn't start down here and go up that way.
Oh, all right. We flip on the other side because of like the negative.
Mhm.
All right.
Okay, so we're up to 42.
Next is let me check this.
I can't remember what you said. There we go to 42.
43 now.
43. All right, so the this one is kind of a standard one to look at. I'm surprised it's here. Because the other ones were more complicated. The one, this right here is a shift right one. So that this vertical asymptote is at x equals 1, and then it just comes up, looks like this, essentially. It's just moved to the right 1 unit.
All right. On to 44.
44. So this is a pretty advanced one because it requires you to understand the domain of this, which I have not emphasized at all. The domain of x squared is obviously minus infinity to infinity. The domain of log base 2 of x, it's only from 0 to infinity. The point is that if you try to put a negative number in here, when you square it, you get a positive number, which is good, right?
Yeah.
And so, like, you might be thinking, well, how does any of that matter? Well, log x looks like this, but because negative values are just as good, it ends up mirroring itself over here on the
Oh,
other side.
so it ends up looking like that.
Yeah.
All right, on the 45.
45, you said.
Mm-hmm.
Explain how the graph of the function can be obtained. Okay, so this is like what we've been doing. It's what I um, it's what I would it's how I would emphasize all this stuff to you, which is where transformations. Like, what is the transformation of this? Because the base graph we know goes like this. So what does x plus 4 do? Well, it goes left 4 units. So you would move every point left 4 units, but it changed the vertical asymptote, and it ends up looking like this.
Oh, okay. So it moves over to the left. Okay.
Okay, which one are we on to? You said 40,
46.
46. Okay. So what is, I mean, can you tell me when you see this, like what the transformation is?
Yeah.
What does x minus 6 do?
To the left 6.
Right 6.
Oh, to the right. I mean, sorry.
Right 6, yeah. So it takes that original graph, which looks like this. They all kind of look the same, and then it just goes over 1, 2, 1, 2, 3, 4, 5, 6, and then it's the exact same thing. It's just right 6.
All right. Next is 48 and 50.
All right, 48. All right, so this one has a few more things that are going on. It doesn't just have one transformation; it's got 3. So here is, this is 1, this is 2, and this is 3 here. So number 1, the 4, it's a vertical stretch of 4. Number 2 is a flip over the x-axis, and number 3 is down 8. So you take that original graph, which looks like this. You're stretching it 4. So all that does is just pull it. So it makes it look more like that and that, but it still goes like that. Flip over the x-axis, so that comes down this way. And then it's down 8, so it's way down here. I don't even have enough room, but it effectively, all these points go down 8. 1, 2, 3, 4, 5, 6, 7, 8. So it ends up looking something more like that when you're done. It's kind
Okay.
of hard to graph in this window, but
So down 8, reflected over the x-axis.
and vertical stretch of 4.
What would the original line look like?
It's this one right here. They all
Okay.
look, the log of x is
What does
all
the new one look like?
this last one kind of down like that.
Why isn't it like I don't know. Never mind.
If you want more depth on this, I gotta go to Desmos. I'm happy to do that, but it's I think all it's looking for is this in terms of getting
The answer?
work done, the answer of what they're looking for.
Oh, okay. I see what you mean. All right. On to 50.
50. It does say to graph it, but your instructor is looking for. They're just looking to see that you apply the transformations appropriately. So this has 2 transformations. This one has this one here and this one here. So number 1 and number 2. Number 1 is a flip over the y-axis.
Oh, over the y? Okay.
Yeah, so if the original, I guess this actually, it should have been like, if this is this, then the new one is this.
Yeah. Makes sense.
And then the flip over the x-axis is number 2.
Oh, I see what you mean.
So it did look like this. Now it's going to look like this.
Yeah.
So your final graph is this one.
All right. I sent you the problems for the next homework for 5.5.
Okay. Standing by for those.
Hopefully it already sent.
checking my email, still not seeing it.
Try that again.
Waiting.
Let's see if it says when I do this.
I mean, it'll come in eventually. It's the way email works. Do you have finals next week, midterms, or whatever they're calling them?
Yeah. Getting ready for that. I have a final review that we can go over when we finish this homework.
Okay. I'm still checking email.
It's for some reason it's glitching out for me. Let's see.
Okay.
Math.com. Learning at mathbymatthew.com, correct?
Yep, that'll work.
This one should send.
All right, I got an image. Looks like a bunch of questions here on exponential equations. Starting at number 9. Where would you like me to start for this?
Number 9.
Number 9. Okay. So it says solve each equation and then approximate, I guess, if necessary. Okay. Let me just type these. I was going to step them in. These are fast enough that I can just do that way. Okay. So number 9 says 3 to the x equals 7. So the only way to get a variable out of the exponent is, do you remember?
Variable out of the exponent. Oh.
You have to use natural log or another log, because what that does is that x comes out in front. So x natural log 3 equals natural log 7. So the answer is natural log or log for these. So you're gonna get x by itself by dividing by natural log of 3 on both sides.
Oh.
So you get x equals natural log of 7 over natural log of 3. And that's why it says round to the nearest thousandth, because you got to go to your calculator. You got to figure out what that is. Log 7 over log 3. Blessed, come on. 1.771.
All right, on to number 11.
11. So 11 is 1/2 to the x equals 5. Same exact thing. How do you get a variable out of the exponent? Well, you have to
X
use
ln 1/2
ln.
equals ln 5 divided by ln 1/2 divided by ln 1/2.
That's right. That's exactly right. So you're going to get, this one's going to be negative because log of a half is a negative number.
Log 5 divided by log 1/2. Negative 2.322.
Okay.
All right. Next is number 33.
33. Solve each logarithmic equation. Okay. All right. Let me get it written down here. 5 natural log of x equals 10. So we want to get this down to natural log of x. Well, to do that, you divide both sides by 5. So you get natural log of x equals 2. To undo natural log, you use e.
Oh.
So here's how this works. You write e to the natural log of x equals e squared. And then e undoes natural log of x, so it just becomes x equals e squared. A lot of people just go to this step right here. There is an intermediate step there. So e is the exponential function. It's like second ln on your
7.390.
Yep. Yeah, got it. You got it. Oh, it says express. Oh, then support your answer with the calculator. Okay. Great. What's next?
Next is 34.
34. 3 log x equals 2. Now you got to be careful here because you can get in the mindset of, oh, it's always e or whatever it is. This is log base 10 of x equals 2/3. Do you follow that?
Yeah.
Okay. Now you do not undo log with e. That's the mistake here. Log is different than ln. You undo log base b of x with b. So let me try to explain that. The base here is 10. So you write 10 to the log base 10 of x equals 10 to the 2/3 power. And on the left, this becomes x. And this is 10 to the 2/3. So we had some problems where you actually had to go from this to this line here and back and vice versa. Maybe you don't remember that now.
So you undo it with 10, so log 10
Yeah.
x 10 2/3. So
So
x equals 10 to
this
2/3.
10 is like the e in the previous problem.
Oh, okay.
And then you can put that in a calculator.
Get like 4.6.
Yep.
All right, next is number 36.
Okay, 36.
ln 2x equals 5.
Okay, so this is ln. So how do you undo ln?
Natural log of e?
You use e. So you write e ln of 2x equals e to the 5. And then e undoes ln, the natural log, so you just write 2x equals e to the 5th.
Wait, 2 divided by 2.
Yeah, so it's 1/2 e to the 5th.
E to the 5th is like 148, then divided by 2. It equals 74.207.
7, yeah.
All right. On to number 39.
39. All right, so 39, they go back and forth. Log base 6. Okay, so how do you undo log base 6? You undo log base 6 with 6 to the power. So it's 6 to the log base 6, 2x plus 4 equals 6 to the 2. Because it's base 6, not ln, you use that number. When it's ln, you use e. So on the left, this just undoes it. It's 2x plus 4 equals 6 squared, which we know is 36. It's 2x plus 4 equals 36. Subtract 4, 2x equals 32, x equals 16.
Makes sense. Next is number 40.
40. Log base 5, 8 minus 3x equals 3. So how do you undo log base 5? You use 5 as the exponent base. So 5 log base 5, 8 minus 3x equals 5 cubed. Again, notice how these numbers always match, and this number matches that. So this always undoes the log part. 5 cubed, we can get to that. So 8 minus 3x equals 125. If you subtract 8 from both sides, you get 117, which actually is divisible by 3. X equals, yep, minus 39. So I know that because you add up the digits and it is a multiple of 3. So it ends up being 9.
Next is 42.
Just probably want to double check that. 117 divided by minus 3 is 39, negative 39. Would you like me to clarify something?
Nah, it's all good.
Okay. What's next?
Number 42.
42. Log base 7 x cubed plus 65 equals 0. So again, you're going to undo the log base 7 with 7. So 7 to the log base 7 of x cubed plus 65 equals 7 to the 0. 7 to the 0 is 1. On the left, it becomes x cubed plus 65. You subtract 65 from both sides, and you get x cubed equals minus 64. Take a cube root of both sides, and you get negative 4.
All right. Let's do number 44 now.
Okay, 44 says, 44, our first kind of variation on the ones that we've been doing here. So 44 is log of x plus log of x squared equals 3. Okay, if you were to combine these logs, do you remember the property that allows you to do that? A sum becomes a product?
Multiplication.
Yeah. So this is really log of x cubed. When the base isn't written, it's 10. So to undo this, you're going to take 10 to the log base 10 of x cubed equals 10 cubed. And so that becomes x cubed equals 10 cubed, or x cubed equals 1,000.
Cube root, and then it's just 10.
X equals 10, yeah.
X is 45, then 49.
45, okay. 45. We have log x plus log x minus 21 equals 2. So
We
again, you're going
multiply
to
x by x minus 21.
exactly equals 2. And then there's a 10 here. Let me just simplify here a little bit. So it's x squared minus 21x
It's
equals 2.
log base 10, and then 10 log base log 10 x squared minus 21x equals, what is it? Is it 10 squared? All right, 10
Yep.
squared. So then x squared minus 21x equals 100.
This is the first time we're going to get two solutions here. So x minus 25, x plus 4 equals 0. So you have two solutions, 25 and negative 4. It's possible that 1 is correct, 2 is correct.
And neither are correct.
Probably never that case, although I think there is. I mean, that'd be really
Rare.
awful. But and it's not the fact that it's positive, but when you look back here, you go back all the way to the original. Can you take the log of a negative number?
Log of a negative number? No.
No. So negative 4 is not allowed.
Oh, so then
But
we know
not
it's
because it's negative, but because the fact that when you put it into the log, it's the log of a negative.
So x equals 25.
So that's, and you're supposed to be like, no, that's not right. That's extraneous. All right. Did you say 49?
Yes, 49.
Log base 5 x plus 2 plus log base 5 x minus 2 equals 1.
X minus 2 equals 1.
All right, so this is log base 5 x plus 2 x minus 2 equals 1.
This turned to x
5.
squared minus 4.
It does. So we get x squared minus 4 equals 5. X squared minus 9 equals 0. So you end up getting two answers here. X minus 3, x plus 3 equals 0. X can be either 3 or minus 3. And again, that minus 3 is extraneous, not because it's minus, but when you put minus 3 back into here or here, either one, you're going to get a negative.
True. Next is 51
1.
through 54.
Okay. All right, let me get caught up to you here. Log base 7, 4x minus log base 7x plus 3 equals log base 7x. All right, on the left side, we can write this as a fraction, 4x over x plus 3. Is that okay?
Yeah.
Equals log base 7 of x. So now, because these are both logs, same thing, you can set the 4x over x plus 3 equal to x. You can set the inside part of this one equal to the inside part of this one, because the logs are the same. And then you just cross multiply to solve this. So it's 4x equals x times x plus 3. 4x equals x squared plus 3x. So we'll move the 4x over. You end up getting x squared minus x. Factor out an x, you get x minus 1. So x can either be 0 or x can be 1. We need to go back and look at the original to see if either of those are problematic. So on the original, it says log base 7 of x on the right-hand side. So that's going to be an issue because you're going to end up putting in log base 7 of 0. Well, this does not exist. It's not part of the domain.
Okay.
So that one's extraneous. I'm trying to think if you ever get them both working. It seems like textbook problems wouldn't allow that. So it's just x equals 1. All right, 52.
Yeah. So x just equals 1.
Say that again.
Never mind. I got it.
Log base 2 of 2x times x plus 2 equals log base 2 of 16. Because they're the same on both sides, you can just set the inside parts equal. 2x times x plus 2 equal to 16. 2x squared plus 4x equals 16. Move the 16 over. I'm going to factor out a 2 because it makes the factoring of the trinomial easier. This becomes x plus 4, x minus 2 equals 0. So you get two answers again. No surprise there. We're getting a bunch of two answer problems. And then, or x equals 2. You'll find that negative 4 is extraneous. So the answer is just 2. X equals 2 in this case.
All right.
53.
Yeah.
Keep hoping this ends.
Mm.
53. So we got so kind of the same thing here, like, but a little extra wrinkle. This 2 needs to come here. Natural log e to the x minus natural log e squared equals natural log e to the 4th. There's another way to do this, but this pattern is what we've been doing. So this becomes natural log e to the x over e squared, because subtraction becomes a division, over natural log e to the 4th. You can set these equal because they're both ln's. So you get e to the x over e squared equals e to the 4th.
Mhm.
And you can cross multiply here. So e to the x equals e to the 4th times e squared. E to the x equals e to the 6th. Because the bases are the same, you can set the exponents equal. So x equals 6. We maybe should do this another way, unless you're just trying to get through this, because that probably wasn't the best explanation. There's probably a better one. Up to you, though.
It's okay.
Okay, so we're on to 54.
Mm-hmm. Last one.
All right, so the outside function here is log base 2. So like, forget about this for a moment. If you're trying to solve log base 2, I'm going to put a u here, equals 1. How would you undo the log base 2? You would say 2 to the log base 2 of u equals 2 to the 1. And u would equal 2 to the 1. So u would equal 2. Well, what was u? U was this. So let's do that again. So log base 2 of x equals 2. How do we undo this? Well, it's 2 to the log base 2 of x equals 2 squared. So x equals 4.
Perfect. I'll send you, share with you a doc.
Okay. What were you hoping to get done in both of these sessions tonight?
I thought that these were going to take much longer than they actually did.
Okay. One of the things that really helped me out is if we could just not have the next session tonight, and I can just reschedule that for whenever you want. And obviously, there's no charge. I would just move it whenever you want.
Oh, good. How about
You don't have to decide right now either, but I need to know in advance so I can move it to whatever day that is, and then you'd have it.
Yeah, can we move that to like a Saturday or something?
Saturday's no good. Sunday's good.
How about Monday?
Monday's good too. What time on Monday do you want?
How about
5, 6?
How about 5?
5. That's easy enough here to do. So you're going to use the same booking link as this one
for 8 o'clock, and then I'll use it at 5 o'clock.
Yes, and I will remind you if I don't see you or something, but I'm going to move it right now, I don't know what it does on your side. For me, I just move it and it's no big deal. But on your side, I don't know what it is. So the 14th at 5 p.m. and I just moved it. I don't think it moves on your side, so you'll just have to keep an eye out for that. but I'll tell you.
All right.
I won't let you forget about that. That actually works out really well for me because I'm running out of energy pretty quickly tonight.
Same.
So if you want to send that over, we can do a few
Yeah.
problems.
Was
Just wait for it.
should send pretty. Wait, no, not request. I don't need to request it. I'll just make a copy. Here we go. Make a copy. Then I'm gonna share it with you. Come on. Here we go. Here we go. That should send.
All right, I do see it. I wonder if this is the same as the one they always give every year. No, it's actually different. Huh. Shocked.
Huh.
Somebody doing something different. Okay. Um, yeah, so should we just start with question one, or is there an area, something else you'd like to start with?
We can just start with question one.
Okay. All right, so simplify the following. This is a multiplication of a binomial. So you're going to take 4 and multiply it by 2, and 4 and 2, 4 and 4i, and so on. So you end up getting the FOIL essentially here. So you get 8 minus 16i plus 6i minus 12i squared. So at a minimum, you ought to be able to get it down to this, but then we need to remember what I squared is. I squared is -1 minus 12 times -1, just substituting that in. So you get 8 minus 10i plus 12. The first and the last can now combine as 20 minus 10i. And let me know if you want another one like this to practice. Yes, no, maybe so.
Yeah, let's go to number 2.
Number 2. Okay. Number 2. So number 2 I find is actually easier than number 1. I don't know why they gave you this, but you need to distribute this negative in here. -2 plus 5i plus 1 minus 2i. Because you're just adding and combining like terms, that's why I said I think it's easier. You're combining the 5i with the minus 2i, the minus 2 and the 1. So it becomes -1 plus 3i is your final answer on that.
All right, on number 3.
Number 3. Number 3 is the square root of -50. So we know that this is the square root of -1 times the square root of 50, and the square root of -1 is I. Okay, so that part's taken care of. We know there's an I in the answer. Okay, good for us, right? The square root of 50, we break up into a factor tree, prime factorization here. So there's 2 5s. You can pull a 5 out. The 2 stays on the inside. You end up getting 5i square root of 2, because that's what's left over.
All right.
Number 4. Number 4 is the classic exam question. It's definitely the one that you're most likely to see. You have to know to multiply the top and bottom by the conjugate. I'm writing down the conjugate here. It's the change in operator. If it's negative, if it's a subtraction, it becomes a addition. If it's addition, it becomes a subtraction. So what we're going to do here is FOIL, essentially, the top and the bottom. So the top becomes 3 plus I minus 6i minus 2i squared. And that becomes 3 plus I minus 6i. And then the I squared again is -1. So this last one becomes a plus 2. So that's a 5 minus 5i. On the bottom, it's 9 plus 3i minus 3i minus I squared, which becomes a 3 plus 3i minus 3i plus 1. Sorry, that's a 9 there. So the middle ones cancel, and you just get a 10 here on the bottom. So it's 5 over 10 minus 5i over 10, 1/2 minus 1/2 I.
Perfect. All right, let's do this
All right.
last one.
Yep, this will close us out here. We got a lot done during this lesson, so good value out of this. So I to the 15th, what you do is you have to know that I to the 4th is equal to 1, I to the 8th is equal to 1, and so on. So you try to figure out, like, what's the nearest multiple of 4? Well, this is I to the 12th times I cubed.
Mm-hmm.
And I to the 12th, well, that's 1. So now I got to figure out, what is I cubed? Well, I is I squared is -1, and I cubed is negative I. So this reduces to negative I times 1 becomes just negative I. If you're really trying to learn this, we really should do a bunch of problems like each one of these, but we didn't have time for that.
That's all right. I think we can just finish with this. Thank you, Matthew.
Yeah, you're welcome. I'll send these out shortly. Thanks again for scheduling. I'll see you Monday.
Appreciate your time.
Okay,
Bye-bye.
bye now.